All right, this is going to be a nice, short little lecture on how to read pedigrees, which is actually a really easy thing to do. Okay, so first off, what is a pedigree? A pedigree is a picture of your family. It's kind of like a family tree. The difference is, though, that you're going to study a hereditary trait, and so you're going to follow it through the family tree. The ones that are the most useful are when there's a big family or there's really, really good records over the generations for the trait that you're trying to study. So how do you read a pedigree? Well, first off, squares are males and circles are females, always. Now, when you have a pedigree on the EOC, it's very likely that they are not going to give you a key. You are going to need to know these pedigree reading rules because it's standard. Okay, so a square is male and a circle is female. Now, if it's not colored in, so if it's just a blank circle or square, then that is an individual who is normal. They don't have the disease that you're studying. If you have the square or the circle colored in, like down here, then they have the disease or trait that you are studying. Okay? Now, this one in the middle that I'm showing as a carrier, not all pedigrees will use this. A lot of pedigrees will only have not shaded for not having the disease or shaded for having the disease. They will not use this heterozygote, but some will, so I want to go ahead and introduce you to it. If they do use it, then there's two ways that they can show a heterozygote or carrier. They can either put a little square inside a square or a little circle inside a circle, or they can shade it half and half, a half shaded square or a half shaded circle. This is supposed to be a circle. I couldn't get the shape to work out right. Okay? But remember, not all pedigrees will use this. They just will want you to figure out who is a heterozygote based on transmission, which we're going to get practice with in just a few minutes. Okay? Okay, now, here is a pedigree. Remember, all the squares represent boys, all the circles represent girls. Okay? Now, you see the line connecting two individuals? This line is a marriage line. This means that they are married. Then you have a line coming down from the marriage line and branching out to the individuals. Those are babies. Okay, these are the offspring. So this person and this person had 1, 2 babies. This person and this person had 1, 2, 3 babies. Okay, so some questions that you may be asked about this other than boys and girls is family relations. So how is this person and this person related? Oh, well, this is the grandmother and this is the grandson. Okay, these are great-grandparents to these great-grandchildren. These individuals are aunt and nephew. Okay, so make sure you understand the family relations. If you don't, call me over and we'll talk family relations together. For now, you're going to see along the side Roman numerals. Each Roman numeral represents a generation. Okay, so they go all the way across. Then you have your Arabic numerals, your regular numbers. To identify an individual, you do the Roman numeral dash the Arabic number. So, for example, individual 3-5 is right here. Okay, Roman numeral 3 over to 5. Okay? All right. Now, notice that on this one, you've got some shaded in every single generation. Okay? Every single generation. If you see shading in every single generation, that lets you know that the trait is dominant. So whatever you're studying is dominant. Okay? So it's in every generation that's dominant. You'll need to be able to recognize that pattern because it will ask. So here's an example of a dominant. Okay. Now let's notice this one. This one doesn't give the Roman numerals, but it does use this sort of pattern of showing you the heterozygote. Okay. Now notice this time you do not have a fully shaded in individual in every single generation. Okay. It kind of skips generations a little bit. So this lets you know that this is recessive. Okay, when it is not in every single generation, when it is rare, then it is recessive. So here's an example of a recessive. Looking at family relations again, up here you have the grandparents and the grandchildren, parents to children. Let's see, you have, this is an uncle to these nieces, okay? This one is going to represent a sex-linked trait. How do I know that this is sex-linked? Because the only ones who have it are boys. Can girls get a sex-linked trait? Yes, but very rarely compared to the boys. So we know this one is sex-linked because only boys are shaded in.